Telegraphy is the long-distance transmission of textual or symbolic messages without the physical exchange of an object bearing the message. Thus, semaphore is a method of telegraphy, whereas pigeon post is not. Telegraphy requires that the method used for encoding the message be known to both sender and receiver. Such methods are designed according to the limits of the signaling medium used. The use of smoke signals, beacons, reflected light signals, and flag semaphore signals are early examples. In the 19th century, the harnessing of electricity led to the invention of electrical telegraphy. The advent of radio in the early 1900s brought about radio telegraphy and other forms of wireless telegraphy. In the Internet age, telegraphic means developed greatly in sophistication and ease of use, with natural language interfaces that hide the underlying code, allowing such technologies as electronic mail and instant messaging. Terminology. The word telegraph was first coined by the French inventor of the semaphore line, Claude Chappie, who also coined the word semaphore. A telegraph is a device for transmitting and receiving messages over long distances, i.e. for telegraphy. The word telegraph alone now generally refers to an electrical telegraph. Wireless telegraphy is also known as CW for continuous wave, as opposed to the earlier radio technique of using a spark gap. Contrary to the extensive definition used by Chappie, Morse argued that the term telegraph can strictly be applied only to systems that transmit and record messages at a distance. This is to be distinguished from semaphore, which merely transmits messages. Smoke signals, for instance, are to be considered semaphore, not telegraph. According to Morse, telegraph dates only from 1832, when Pavel Shigeling invented one of the earliest electrical telegraphs. A telegraph message sent by an electrical telegraph operator, a telegrapher using Morse code, was known as a telegram. A cablegram was a message sent by a submarine telegraph cable, are often shortened to a cable or a wire. Later, a telex was a message sent by a telex network, a switched network of teleprinters similar to a telephone network. A wire picture, a wire photo, was a newspaper picture that was sent from a remote location by a facsimile telegraph. A diplomatic telegram, also known as the diplomatic cable, is the term given to a confidential communication between a diplomatic mission and the foreign ministry of its parent country. These continue to be called telegrams or cables regardless of the method used for transmission. History. Even though early telegraphic precedents, such as signaling through the lighting of pyres, have existed since ancient times, long-distance telegraphy started in 1792 in the form of semaphore lines, or optical telegraphs, that sent messages to a distant observer through line-of-sight signals. Commercial electrical telegraphs were introduced from 1837. Optical telegraph. The first telegraphs came in the form of optical telegraph, including the use of smoke signals, beacons, or reflected light, which have existed since ancient times. Early proposals for an optical telegraph system were made to the Royal Society by Robert Hooke in 1684 and were first implemented on an experimental level by Sir Richard Lovell Edgeworth in 1767. The first successful semaphore network was invented by Claude Chappie and operated in France from 1792 through 1846. During 1790 to 1795, at the height of the French Revolution, France needed a swift and reliable communication system to thwart the war efforts of its enemies. In 1790, the Chappie brothers set about devising a system of communication that would allow the central government to receive intelligence and to transmit orders in the shortest possible time. On the 2nd of March 1791 at 11 a.m., they sent the message: "Si vous réussissez, vous serez bientôt couverts de gloire," between Brouillon and Pass, a distance of 16 kilometers. The first means used a combination of black and white panels, clocks, telescopes, and code books to send the message. In 1792 Claude was appointed ingénieur télégraphiste and charged with establishing a line of stations between Paris and Lille, a distance of 230 kilometers. It was used to carry dispatches for the war between France and Austria. In 1794, it brought news of a French capture of Condé-sur-Risco from the Austrians less than an hour after it occurred. The Prussian system was put into effect in the 1830s. However, they were highly dependent on good weather and daylight to work, and even then could accommodate only about 2 words per minute. The last commercial semaphore link ceased operation in Sweden in 1880. As of 1895, France still operated coastal commercial semaphore telegraph stations for ship-to-shore communication. Electrical telegraph's early developments. The first suggestion for using electricity as a means of communication appeared in the Scots magazine in 1753. Using one wire for each letter of the alphabet, a message could be transmitted by connecting the wire terminals in turn to an electrostatic machine, and observing the deflection of pith balls at the far end. Telegraphs employing electrostatic attraction were the basis of early experiments in electrical telegraphy in Europe, but were abandoned as being impractical and were never developed into a useful communications system. One very early experiment in electrical telegraphy was an electrochemical telegraph created by the German physician, anatomist, and inventor Samuel Thomas von Summering in 1809, based on an earlier, less robust design of 1804 by Spanish polymath and scientist Francisco Salva Campillo. Both the designs employed multiple wires in order to visually represent most Latin letters and numerals. Thus, messages could be conveyed electrically up to a few kilometers, with each of the telegraph receiver's wires immersed in a separate glass tube of acid, as an electric current was applied by the sender representing each digit of a message. It would at the recipient's end electrolyze the acid in its corresponding tube, releasing a stream of hydrogen bubbles next to its associated letter and numeral. The telegraph receiver's operator would visually observe the bubbles and could then record the transmitted message, albeit at a very low baud rate. The first working telegraph was built by the English inventor Francis Ronalds in 1816 and used static electricity. At the family home on Hammersmith Mall, he set up a complete subterranean system in a 175-yard-long trench as well as an 8-mile-long overhead telegraph. The lines were connected at both ends to clocks marked with the letters of the alphabet, and electrical impulses sent along the wire were used to transmit messages. Offering his invention to the Admiralty in July 1816, it was rejected as wholly unnecessary. His account of the scheme and the possibilities of rapid global communication in descriptions of an electrical telegraph and of some other electrical apparatus was the first published work on electric telegraphy, and even described the risk of signal retardation due to induction. Elements of Ronald's design were utilized in the subsequent commercialization of the telegraph over 20 years later. An early electromagnetic telegraph design was created by Russian diplomat Pavel Schilling in 1832. He set it up in his apartment in St. Petersburg and demonstrated the long-distance transmission of signals by positioning 2 telegraphs of his invention in 2 different rooms of his apartment. Schilling was the first to put into practice the idea of a binary system of signal transmissions. Carl Friedrich Gauss and Wilhelm Weber built the first electromagnetic telegraph used for regular communication in 1833 in Göttingen, connecting Göttingen Observatory and the Institute of Physics, covering a distance of about 1 kilometer. The setup consisted of a coil that could be moved up and down over the the end of two magnetic steel bars. The resulting induction current was transmitted through two wires to the receiver, consisting of a galvanometer. The direction of the current could be reversed by commuting the two wires in a special switch. Therefore, Gauss and Weber chose to encode the alphabet in a binary code, using positive and negative currents as the two states. Commercial telegraphy. Telegraph networks were expensive to build, but financing was readily available, especially from London bankers. By 1852, national systems were in operation. Major countries as follows: United States, 20 companies with 23,000 miles of wire. Great Britain, Cook Wheatstone Company and minor companies with 2,200 miles of wire. Prussia, 1,400 miles of wire. Siemens system. Austria, 1,000 miles of wire. Siemens system. Canada, 900 miles of wire. France, 700 miles of wire. Optical systems dominant. Australia, 0. First line opened in 1854. Cook and Wheatstone system. The first commercial electrical telegraph was co-developed by Sir William Fothergill Cook and Charles Wheatstone. In May 1837 they patented the Cook and Wheatstone system, which used a number of needles on a board that could be moved to point to letters of the alphabet. The patent recommended a 5-needle system, but any number of needles could be used depending on the number of characters it was required to code. A 4-needle system was installed between Euston and Camden Town in London on a rail line being constructed by Robert Stevenson between London and Birmingham. It was successfully demonstrated on the 25th of July 1837. Euston needed to signal to an engine house at Camden Town to start hauling the locomotive up the incline. As at Liverpool, the electric telegraph was in the end rejected in favour of a pneumatic system with whistles. Cook and Wheatstone had the first commercial success with a system installed on the Great Western Railway over the 13 miles from Paddington Station to West Drayton in 1838, the first commercial telegraph in the world. This was a 5-needle, 6-wire system. The cables were originally installed underground in a steel conduit. However, the cables soon began to fail as a result of deteriorating insulation and were replaced with uninsulated wires on poles. As an interim measure, a 2-needle system was used with 3 of the remaining working underground wires, which despite using only 2 needles had a greater number of codes. But when the line was extended to Slough in 1843, a 1-needle, 2-wire system was installed. For this point, the use of the electric telegraph started to grow on the new railways being built from London. The London and Blackwall Railway was equipped with the Cook and Wheatstone telegraph when it opened in 1840, and many others followed. The 1-needle telegraph proved highly successful on British railways, and 15,000 sets were still in use at the end of the 19th century. Some remained in service in the 1930s. In September 1845, the financier John Lewis Ricardo and Cook formed the Electric Telegraph Company, the first public telegraphy company in the world. This company bought out the Cook and Wheatstone patents and solidly established the telegraph business, as well as the rapid expansion of the use of the telegraphs along the railways. They soon spread into the field of mass communication, with the instruments being installed in post offices across the country. The era of mass personal communication had begun. Morse system and electrical telegraph was independently developed and patented invented in the United States in 1837 by Samuel Morse. His assistant, Alfred Vail, developed the Morse code signaling alphabet with Morse. The first telegram in the United States was sent by Morse on the 11th of January 1838, across 2 miles of wire at Speedwell Iron Works near Morristown, New Jersey, although it was only later, in 1844, that he sent the message "What hath God wrought?" from the Capitol in Washington to the old Mount Clair Depot in Baltimore. From then on, commercial telegraphy took off in America, with lines linking all the major metropolitan centers on the East Coast within the next decade. The overland telegraph connected the west coast of the continent to the east coast by the 24th of October 1861, bringing an end to the Pony Express. The Morse telegraphic apparatus was officially adopted as the standard for European telegraphy in 1851. Only Great Britain, with its extensive overseas empire, kept the needle telegraph of Cook and Wheatstone. In 1858, Morse introduced wired communication to Latin America when he established a telegraph system in Puerto Rico, then a Spanish colony. The line was inaugurated on March 1, 1859, in a ceremony flanked by the Spanish and American flags. Another early system was that of Edward Davy, who demonstrated his in Regent's Park in 1837 and was granted a patent on the 4th of July 1838. He also developed an electric relay. Telegraphic improvements. Telegraphy was driven by the need to reduce sending costs, either in handwork per message or by increasing the sending rate. While many experimental systems employing moving pointers and various electrical encodings proved too complicated and unreliable, a successful advance in the sending rate was achieved through the development of telegraphies. The first system that didn't require skilled technicians to operate was Sir Charles Wheatstone's ABC system in 1840, where the letters of the alphabet were arranged around a clock face, and the signal caused a needle to indicate the letter. This early system required the receiver to be present in real time to record the message, and it reached speeds of up to 15 words a minute. In 1846, Alexander Bain patented a chemical telegraph in Edinburgh. The signal current made a readable mark on a moving paper tape soaked in a mixture of ammonium nitrate and potassium ferrocyanide, which gave a blue mark when a current was passed through it. David Edward Hughes invented the printing telegraph in 1855. It used a keyboard of 26 keys for the alphabet and a spinning type wheel that determined the letter being transmitted by the length of time that had elapsed since the previous transmission. The system allowed for automatic recording on the receiving end. The system was very stable and accurate and became the accepted around the world. The next improvement was the Baudot code of 1874. French engineer Émile Baudot patented a printing telegraph in which the signals were translated automatically into typographic characters. Each character was assigned a unique code based on the sequence of just 5 contacts. Operators had to maintain a steady rhythm, and the usual speed of operation was 30 words per minute. By this point reception had been automated, but the speed and accuracy of the transmission was still limited to the skill of the human operator. The first practical automated system was patented by Charles Wheatstone, the original inventor of the telegraph. The message was typed onto a piece of perforated tape using a keyboard-like device called the stick punch. The transmitter automatically ran the tape through and transmitted the message at the then exceptionally high speed of 70 words per minute. teleprinters. Teleprinters were invented in order to send and receive messages without the need for operators trained in the use of Morse code. A system of two teleprinters, with one operator trained to use a typewriter, replaced two trained Morse code operators. The teleprinter system improved message speed and delivery time, making it possible for messages to be flashed across a country with little manual intervention. Early teleprinters used the E-to-1 baud code, a 5-bit code. This yielded only 32 codes, so it was over-defined into two shifts, letters, and figures. An explicit, unshared shift code prefaced each set of letters and figures. In 1901, baud's code was modified by Donald Murray, and around 1930, the CCITT introduced the International Telegraph Alphabet No.2 code as an international standard. By 1935, message routing was the last great barrier to full automation. Large telegraphy providers began to develop systems that used telephone-like rotary dialing to connect teletypewriters. These machines were called telex. Telex machines first performed rotary telephone-style pulse dialing for circuit switching, and then sent data by baud code. This type A telex routing functionally automated message routing. Telex began in Germany as a research and development program in 1926 that became an operational teleprinter service in 1933. The service was operated by the Reichspost and had a speed of 50 baud, approximately 66 words per minute, at the rate of 45.45 baud, considered speedy at the time. Up to 25 telex channels could share a single long-distance telephone channel by using voice-frequency telegraphy multiplexing, making telex the least expensive method of reliable long-distance communication. Automatic teleprinter exchange service was introduced into Canada by CPR Telegraphs and CN Telegraph in July 1957, and in 1958, Western Union started to build a telex network in the United States. Beginning in 1956, telegrams began to be transmitted over the telex network using the ITUF-20 standard named Gentex in order to lower the costs for some European telecommunications companies by allowing the sending telegraph station to connect directly to the receiving station. Oceanic telegraph cables. Soon after the first successful telegraph systems were operational, the possibility of transmitting messages across the sea by way of submarine communications cables was first mooted. One of the primary technical challenges was to insulate the submarine cables sufficiently to prevent the current from leaking out into the water. In 1842, a Scottish surgeon, William Montgomery, introduced gutta percha, the adhesive juice of the Palaquium gutta tree, to Europe. Michael Faraday and Wheatstone soon discovered the merits of gutta percha as an insulator, and in 1845, the latter suggested that it should be employed to cover the wire which was proposed to be laid from Dover to Calais. It was tried on a wire laid across the Rhine between Deutz and Cologne. In 1849, C.V. Walker, electrician to the Southeastern Railway, submerged a 2-mile wire coated with gutta percha off the coast from Folkestone, which was tested successfully. John Watkins Brett, an engineer from Bristol, sought and obtained permission from Louis Philippe in 1847 to establish telegraphic communication between France and England. The first undersea cable was laid in 1850 and connected London with Paris. After an initial exchange of greetings between Queen Victoria and President Napoleon, it was almost immediately severed by by a French fishing vessel. The line was relaid the next year and then followed by connections to Ireland and the Low Countries. The Atlantic Telegraph Company was formed in London in 1856 to undertake to construct a commercial telegraph cable across the Atlantic Ocean. It was successfully completed on the 18th of July 1866 by the ship SS Great Eastern, captained by Sir James Anderson after many mishaps along the way. Earlier transatlantic submarine cables installations were attempted in 1857, 1858 and 1865. The 1857 cable only operated intermittently for a few days or weeks before it failed. The study of underwater telegraph cables accelerated interest in mathematical analysis of very long transmission lines. An overland telegraph from Britain to India was first connected in 1866 but was unreliable, so a submarine telegraph cable was connected in 1870. Several telegraph companies were combined to form the Eastern Telegraph Company in 1872. Australia was first linked to the rest of the world in October 1872 by a submarine telegraph cable at Darwin. This brought news reportage from the rest of the world. The telegraph across the Pacific was completed in 1902, finally encircling the world. For the 1850s until well into the 20th century, British submarine cable systems dominated the world system. This was set out as a formal strategic goal, which became known as the All-Red Line. In 1896, there were 30 cable-laying ships in the world and 24 of them were owned by British companies. In 1892, British companies owned and operated two-thirds of the world's cables, and by 1923, the share was still 42.7%. During World War I, Britain's telegraph communications were almost completely uninterrupted, while it was able to quickly cut Germany's cables worldwide.